Good morning, class. I'm Dr. Parkinson of Chemistry Department. I'll be taking you gravimetry throughout this course. Dr. Oyiola took you statistics and UV analysis. Dr. Oluseyi has been taking and is still taking you titrimetry. I'll be dwelling on gravimetric analysis. Gravimetric analysis is a classical method of analysis. How many of you have ever taken measurements on this type of scale? You've ever climbed on the scale to weigh yourself? If you did, then you did a kind of gravimetric analysis. Anytime you measure things in grams, you're doing a kind of gravimetric analysis. But specifically, when we refer to gravimetric analysis, we are looking at having an analyte plus a reagent to bring us precipitate that we can measure. So when I talk about gravimetric analysis of analytes in particular, this is what we refer to, and is one of the oldest analytical methods, very precise. It measures mass. And so there are different types of gravimetric analysis. We have the precipitation gravimetric analysis, volatilization, we have the electrogravimetry and atomic mass spectrometry. But we are most interested in precipitation gravimetry in this course. And like I said, in precipitation gravimetry, we usually will have an analyte of interest and then a reagent, which is called the precipitating reagent, that comes in touch with the analyte of interest. Usually it's already in solution, and on reacting, it forms a precipitate, a solid. Precipitate is a solid containing what we're interested in, formed. So when the solid is formed, that solid is usually what is measured. That is in precipitative analysis. But in volatilization gravimetry, here the analyte is separated from other constituents of sample by conversion to a gas of known chemical composition. The analyte is separated from other constituents of a sample by conversion to a gas of known chemical composition. And then the weight of this gas then serves as a measure of the analyte concentration. In this method, the analyte or its composition product are volatilized, collected and weighed. Or sometimes the mass of the volatilized compound is determined indirectly by the loss in mass of the residue. So in volatilization, you have a sample, it's usually a solid, that when heated will release gases. These gases are either gases of decomposition, are usually products of decomposition. So because there's a release, the residue left is way lighter. Another way, these gases can be trapped. And once trapped, they can be weighed. However, in electrogravimetry, it's usually electrolysis, like electrolysis. But here, we're not just interested in measuring current. In electrolysis, you're interested in measuring current that flows. Here, before the electrolysis, you weigh your electrodes. And after the electrolysis, you weigh your electrodes. Now, what is deposited, the difference in before and after, is what is ascribed to the graph. Ascribed is measured in grams, and from calculations can know the amount of analyte that was deposited, and hence the concentration of analyte in that solution. We have atomic mass spectrometry. Here, the atomic mass spectrometer is used to separate gaseous ions from other elements making up the sample of the matter. So when you separate, the masses of these elements are measured, and that way the mass is known. We have combustion analysis. Combustion analysis is like volatilization gravimetry, but here the samples are burned bonds, usually in a furnace, and the residue is measured. We're not interested in any way in the gas component. Meanwhile, we have thermogravimetry. This measures the weight, the change in weight of samples with respect to temperature. So a sample, when heated at 300 degrees, is known to decompose to a particular substance of known mass. And so, by weighing the mass of that substance available, we have an idea of the mass of analyte of interest. And then at certain temperature, you know the other maybe changing the temperature a little more, you know the residue that will be there at that point, and can relate it chemically by equation to the original substance, of or analyte interested in. In gravimetric analysis, to ensure selectivity, you must use the right kind of precipitating agent to precipitate the analyte, because the measurement, gravimetric measurement on its own, is not taking the mass on its own, is not selective, but the process leading to before taking the mass can be made very selective. Usually the process is usually a multi-process step, gravimetric analysis, but generally speaking, we are just trying to convert the analyte to a form that can be measured. We measure the mass, and then the mass, and usually these mass are things that are substances of known chemical composition. What are the advantages of gravimetric analysis? It is precise, and we can measure it with high degree of accuracy. We can use gravimetric analysis to determine mass of elements and atom of elements. We don't need standards to calibrate them. Instead, it can be used to calibrate other instruments. It is relatively inexpensive, and errors can be easily checked. Since we can repeat the experiment, we can resolve the impurity, a lot of things can be done. However, it is limited because that is the disadvantage. The disadvantage is that you can't use this method for many types of analytes because of the problem associated with choosing a very selective precipitate. And we said it is accurate and precise, but this again depends on the experience and quality of the analyst. And it's only suitable for very highly concentrated solutions of analyte. When the analyte solution is low, we won't get very accurate results. However, when solutions are low, when the concentration of an analyte is low, it can be enhanced by standard addition. Standard addition it can be improved to make this method applicable under certain conditions. It can be low concentrated solution of analyte can still be taken by doing standard addition. Standard addition, you add a known amount of analyte to an unknown, and so when the total is generated, you subtract the known, and the remaining concentration is due to the unknown. It is laborious. Since it is manual, it's laborious. Now, you take this assignment. I'll give you some assignments at the end of this presentation. In gravimetry, we have desirable properties of analyte, of precipitate, The precipitate must be readily filtered, readily purified, must be of low solubility so we don't lose the analyte during washing. The stable form, the final form must be stable and not reactive, and usually the analyte must be of known composition after drying or ignition.